This is Radhika. I am going to discuss about power electronics devices. This is for fifth semester electrical students. In last classes, we discussed about the power electronics devices, ratings of SCR. Under that, we discussed about the voltage rating, current rating, and also we discussed about the diac and symbols. So, VI characteristics of SCR. So, today we are going to discuss about the triac. Triac means triode, it works on AC. And in last class, we discussed about the diac. So, now I am just briefly discussion about DIAC. Actually, what is DIAC? So actually, the DIAC means the word diac is obtained from capital letters. Diac that can work on AC means it's the alternating current. It is a two-terminal means two electrodes device which can conduct in either direction, hence is called bidirectional. So here in this diac, the cross-sectional view of diac, it consists of four layers PN, PN and PN, PN dash. So in each and every thyristor family, each and every device has the four layer and three terminals. So diac also it has the four layer and only two terminals T1 and T2. The terminals are connected P region of silicon separated by N region. So already we have seen the symbol of diac in last class. So when the terminal T1 is positive with respect to T2, the layers PN start conducting when the voltage of T1 is more than breakover voltage VBO1. Once the conduction starts, the current through the diac becomes very large and is limited by the external resistance in the circuit. In case of when the terminal T2 is positive with respect to T1, the layers PN dash starts conducting when the voltage of T2 is more than breakover voltage VBO2. In both cases, the currents during blocking regions are very small and we are called as leakage currents. The behavior in both directions are similar because doping level is same in all the layers in two directions. Generally, the breakover voltage of diac is about 30 to 50 volts and the voltage drop is across the device is about 3 to 5 volts. As compared to triac, the operating characteristics of diac is similar but it has no gate terminal. So hence it is called the gateless triac. So this DIAC will be used in as a triggering device for triac and light dimming circuits, and also this will be used in heat controlling circuits, and also it will be used in universal motor speed controls. So in this also the VI characteristics are same as SCR, but it will be connects in reverse bias also. So this is the brief discussion about the diac. Now today our main topic is triac. Today we are going to discuss about triac. In this triac today we are going to discuss about constructional details of triac, cross-sectional view of triac, VI characteristics of triac, advantages and disadvantages of triac, and finally we are going to discuss about applications of triac. So here in this actually what is triac? So it is the major drawback of an SCR is it can conduct current in one direction only. Hence, SCR can control DC power or forward biased half cycle. Forward bias half cycle. So, SCR can control DC power or forward biased half cycle of AC. However, in AC system, it is very necessary to control over both the positive and negative half cycles. For this purpose, a semiconductor device is called triac. It is a combination of two SCRs connected in anti-parallel. So, the triac is the bidirectional triode, and it is a combination of two SCRs. The SCRs will be connected in anti-parallel and it can work on alternating current. It is a bidirectional device, means that it can conduct in both the direction, means T1 to T2, T2 to T1. It can work in both directions. So here, this is the diagram of triac. The triac also has a 4 layers, PN, PN, and this is the symbol of triac. This is the construction view of the triac, and this is the symbol of triac. So, in SCR, it has the some drawback. So, it can conduct current in one direction only. In SCR, the current flow in forward direction, not in reverse. Hence, SCR can control DC power or forward biased half cycle of AC. However, in an AC system, it is very necessary to control over both positive and negative half cycles. For this purpose, a semiconductor device called triac. It is a combination of two SCRs connected in anti-parallel. So here the word triac is obtained from capital letters, means triode that can work on AC. Actually triac means triode that can work on AC. It is a 3-terminal device which can conduct in both the directions. Means here just you can see the symbol. It has the 2-terminal T1 and T2. The triac will conduct T1 as positive and T2 as negative, and also it works as T2 as positive and T1 as negative. So this is the 2-directional device. So hence it is called bidirectional device. So in this diagram just you can observe it also PN layer, and also at a positive P1 material it will be doped with N4, and at P2 semiconductor material the N2 and N3 also doping. So here in this the construction view of triac. So it consists of 4 layers, 3 terminals. The 3 terminals means T1, T2 and gate terminals. So the gate terminal is near to T1 terminal. So the gate terminal is near to T1 terminal. The terminal T1 makes contact with layers N2 and P2. Terminal T2 makes contact with layers P1 and N4 and gate terminal. It makes contacts with layers N3 and P2. So here this configuration is necessary for conducting the triac in both directions, and also for giving triggering pulse to the gate terminal, which is either positive or negative with respect to terminal T1. So here in this, this configuration is necessary for conducting the triac in both directions and also for giving triggering pulse to the gate terminal which is either positive or negative with respect to terminal T1. Since triac is a bidirectional device, the operating characteristics are similar in the first and third quadrant. If gate signal is not applied the triac, breakover voltages are VBO1 and VBO2 at terminal 2, means in reverse bias. And if the gate current is increased, the breakover voltage is reduced. So here in this construction, when we are giving the gate signal, so the gate signal is near to P2 and N3 material, and the T1 terminal is near to P2 and N2 material, and the T2 terminal is near to N4 and T1 material. So this is the symbol for triac. So this is the construction of triac. So in this, it is also 4-layer 3-terminal device. The 3 terminals are T1, T2 and G. The terminal T1 makes contact with layer N2 and P2. The terminal T2 makes contact with layers P1 and N4. The gate terminal makes contact with layer N3 and P2. So this discussion will from this diagram, this constructional view of the triac. So in this, the VI characteristics of triac. So here in this, same as like SCR or diac, the triac also have same VI characteristics, but the SCR will conduct in forward bias only. The diode will be conducts in forward and reverse, same as the triac will be works in forward and reverse. So in this triac, the SCRs will be connected in anti-parallel connection. So that's why one SCR will works on first quadrant in VI characteristics, and second SCR will be worked in third quadrant. So in this, the triac can operate either positive or negative control voltages. But in normal operation, the gate voltage is positive in first quadrant and negative in third quadrant. So actually the two SCRs are connected in anti-parallel in this triac. So one SCR will be worked in first quadrant and second SCR will be worked in third quadrant. The supply voltage at which the triac is turned on depends on the gate current. So when the gate signal is turned on, that time only the voltage is supplied to terminals. If gate signal is not applied, the triac breakover voltages are VBO1 and VBO2. If a gate signal is applied, the breakover voltage is reduced. So here this is the diagram for VI characteristics of triac. This is the diagram for VI characteristics of triac. So in this first quadrant it has the T2 positive, and in third quadrant there is the T2 is negative. So in this As the track can conduct in both the directions, the term anode and cathode are not applicable to track. Its three terminals are usually designated as T1 and T2 and also G as gate. When the voltage applied is less than breakover voltage means VBO1, VBO2 and gate signal is not applied, then track is in blocking state for both the directions. So here in positive half cycle in first quadrant the breakover voltage is VBO2 and here in third quadrant is the breakover voltage VBO1. The track can be turned on in each half cycle of applied voltage by applying a positive or negative voltage to the gate with respect to terminal T1. The first quadrant characteristics is just like SCR. But third quadrant characteristics of track is identical to its first quadrant, except that as the polarities of the main terminal changes causes the direction of current also changes. In first quadrant and in third quadrant way characteristics are different. So in this, track is turned on in each half cycle by applying a positive or negative to the with respect to terminal T1. So in this the features of VI characteristics are the VI characteristics of track in the first and third quadrant are identical to those of SCR in the first quadrant. The track can be operated with either positive or negative control voltage but in normal operations. Usually the gate voltage is positive in quadrant 1 and negative in quadrant 3. The supply voltage at which the track is turned on depends upon the gate current. The track turn on voltage decreases as the gate current increases. The supply voltage at which the track is turned on that will be depends upon the gate current. The track turned on voltage decreases as the gate current increases. So here in this it also few advantages. The track is have some advantages that are track may be triggered with positive and negative polarity voltages. The track needs a single heat. Track needs a single heat sink of slightly larger size, whereas equivalent anti-parallel thyristor pair needs two heat sinks of slightly smaller size. Track needs a single heat sink of slightly larger size, whereas equivalent anti-parallel thyristor pair needs two heat sinks of slightly smaller size. Track needs a single fuse for friction, which simplifies construction. In certain DC applications, SCR needs a diode in its parallel to protect it against reverse voltage. A track does not need a diode in parallel since safe breakdown in either direction is possible. So these are the few advantages of track, and also we have the few disadvantages of track. In this, the tracks have low dV by dt ratings as compared to SCRs. Tracks have lower maximum ratings compared to SCR. Track can be triggered in either direction. Hence, a trigger circuit with the track requires careful consideration, and the tracks have smaller reliability than SCRs. So here the track will be applied in few circuits. The applications of track is speed control of single phase induction motor. It will be used in temperature control circuits, and the track will be used in liquid level controllers. It will be used in phase control circuits and in illumination level controls, and also it will be used in power switches. Now uh, I am discussed now we discussed about the track, and also we can watch the one YouTube video same for the track.
Electronics lecture series. Here in this session I'll be going to discuss about triac, and these are my session outlines, where first I'll explain what is the meaning of triac, then we'll see some uses of triac, then we'll observe symbol of triac, then I'll explain triac equivalent circuit, then we'll see characteristic of triac, and at the end we'll conclude this session with applications of triac. So let us begin this session with first point, that is meaning of triac. So triac means triode for alternating current. Triac means triode for alternating current. So TRI, that is there in triac, like this, and then this A, and then this C. So ultimately triode for alternating current. So it is a triode for alternating current, means it is advanced version of diode, which is what triode. And in diode, as we know, once it is in forward bias it will get conducted, but in triode, by having a controlled signal, we can have a conduction in forward bias. So that is what difference in between diode and triode. Triode is having a controlling third terminal, and diode does not have any controlling third terminal. But triac means triode for alternating current. You will come to know like what is that exact meaning after having this session. So this is what the basic full form of this. And then what is the use of triac? So unlike SCR, we can trigger this in both of the direction. In SCR, we have facility to trigger SCR in forward bias only, but triac can trigger in both of the direction. So unlike SCR, triac can trigger in both direction. Unlike SCR, triac can trigger in both direction. Now let us have a symbol of triac. So symbol of triac is, it is 3-terminal device. This is MT1, let us say this is MT2, and third terminal this is gate. So this triac is 3-terminal device, and it is bidirectional device. So triac could be even considered as two back-to-back SCRs are connected. So triac is 3-terminal device, MT1, MT2 and gate. Let us try to understand this triac by its equivalent circuit. So if I say this is what triac which I have right now, So this is MT1, this is MT2, and this is gate terminal. Now equivalent circuit of this, that is explaining SCRs are connected, two back-to-back SCRs are connected. So ultimately one can clearly understand that, like, this is MT1 and two back-to-back SCR means one SCR is connected like this and other SCR this is MT2 and gate of both of the SCR are connected. So its equivalent circuit is two back-to-back SCR and a gate of both of the SCR is combined together. So ultimately when we talk about its operation, if MT1 is positive with respect to MT2, then this SCR, let us say this is T1, so T1 SCR that is getting triggered in forward bias and T2 that is in reverse bias, and MT2 is positive with respect to MT1. At that time T2 is in forward bias and T1 is in reverse bias. So in both of the cases there will be a characteristic of SCR provided gate control is there. So when we see its characteristic, like if MT1 is positive with respect to MT2, so at that time this T1 is in forward bias and T2 is in reverse bias. So one can clearly say its characteristic is like this. And here we have gate control even. So as we increase gate current, triggering will get earlier. And if I say this is for IG1, this is for IG2, and this is for IG3, then here IG3 is greater than IG2 is greater than IG1. It means as gate current increases, forward voltage decreases. So this is how characteristic is there when MT1 is positive with respect to MT2. Now when we talk about MT2 is positive with respect to MT1, so at that time we'll be having T2 SCR in forward bias and T1 SCR in reverse bias. So during that time period one can clearly see T2 will be in forward bias and T1 will be in reverse bias. So its characteristic is similar to forward bias SCR characteristic, which will be the characteristic of T2, and once it get triggered its current will be like this. And here even there will be two cases, three cases are possible, like as you increase gate current, forward breakover voltage will decrease. So this is what I am observing, like as if I increase gate current, as we have seen it for MT1 is positive with respect to MT2. Let us say this is for IG1 is for IG2 and this is for IG3. So here IG3 is greater than IG2 is greater than IG1, where forward breakover voltage decreases as gate current increases, and that is what the case which we have it for MT2 is positive with respect to MT1. So that is how we have triac and that is bidirectional device and it has controlled in both of the direction. So this is how it differs from SCR. When we talk about diac, it is even bidirectional device but there is no gate control. But when we talk about triac, it is a bidirectional device with gate control. So there are so many applications which is there regarding triac. Let us discuss few. It could be utilized in lamp control. We use that in speed control of fans. It could be utilized in chopper and in AC phase control. We can use it. So that many applications are there regarding triac. Thank you so much for watching this video. If you have any question regarding this topic, then place your questions in comments.
So we watched the YouTube video, same discussion of the track. So here, in discussion with the track, it has the some difference between DAC. So the track will be same as SCR, but two SCRs will be connected anti-parallel. So that's why the track will works in forward direction as well as reverse direction. So actually, what is the comparison of SCR and track? So just we can discuss a few more points. So actually SCR, it has the 4-layer 3-terminal device already we discussed. In triac, it is formed by connecting two SCRs in anti-parallel. In SCR, it is a unidirectional device, but in triac, it is the bidirectional device. In SCR, high power handling capacity. In triac, low power handling capacity. The SCR will be triggered by a narrow positive pulse applied at the gate terminal. In triac, it is triggered either by positive or negative gate terminal. In SCR, it has the fast turn off and hence it can be used to switch AC supply frequencies up to a few kilohertz. Same as in triac, it has more turn off time, hence its applications are limited up to only 400 hertz. So uh, in this class, we discussed about the constructional details of triac, cross-sectional view of triac, VI characteristics of triac, and identical to those of SCRs in first quadrant and third quadrant. And also we discussed about the applications of triac. So here we have the few quiz questions and few frequently asked questions. So today our topic is completed. In next class we are going to discuss about the commutation of SCR. So the commutation of SCR has the many classes like Class A commutation, Class B commutation, Class C commutation, Class D commutation, Class E commutation, and Class F commutation. In next class, we will discuss about the commutation of SCR. Thank you.